Chapter 1, paragraph 7, please, is video only, so not for HAVO students. You can, however, watch the video if you want to, but you don't have to. Okay, it's about structure and bonds. It's about atoms again, so an atom is a building block of a molecule, which we already know, but now we're going to talk about the structure of an atom. And an atom is built of three things: protons, neutrons, and electrons. The protons and neutrons are in the nucleus, and this is around the nucleus. And this is what they call electron cloud. Don't ask me why. So basically there's a nucleus with protons and neutrons, and then there are electrons around it. They are in shells around it. So protons and neutrons in a nucleus, and the electrons are around the nucleus. Okay, so you can define the number of protons, neutrons, and electrons by knowing something about the atom. A proton and a neutron, a proton is always equal to the atomic number. When you go back to the periodic table in your book, you will find numbers with all the elements. So there's 1 in hydrogen, 2 in helium, 3 lithium, 4 beryllium, and so on. And those are atomic numbers, and that is the number of protons that you have in an atom. So 1 hydrogen, 2 lithium, so lithium has 3 protons. So that is how you know the number of protons is always equal to the atomic number, always. There's never ever an exception. So it's always the same. So the number of electrons equals the number of protons, since a proton has a positive charge and an electron has a negative charge. So the two of them are equal to balance out the charge. So is equal to protons plus or minus the charge. If I have, for example, Mg2+, this means that I have fewer electrons than I have protons, because an electron is negative, I have a positive charge, so I must have more protons than I have electrons. There's also O2 minus. 2 minus means I have more electrons than I have protons, since it's negatively charged and electron is negative, so I must have more electrons than I have protons. Okay, so when I want to know the number of protons and electrons in these two, I go to the periodic table and I'm gonna look for magnesium, and I find it here. Magnesium has atomic number 12, so that means it has 12 protons. I have 2+, so that means I have 2 more protons than I have electrons, so the electrons must be 10. The O2 minus is here O. O has atomic number 8, so this has 8 protons. I have 2 more electrons than I have protons, so that means this one has also 10 electrons. So you can see that the electrons are equal while the protons are not. So they are different kinds of atoms, but because of their charge they have an equal amount of electrons. So the electrons are exactly the same. When you look at the bonding of those atoms, so the bonding, there are 3 kinds of bonds. They are the covalent bond, And a covalent bond is only when there are only nonmetals. So there are only nonmetals. So that means, going back to the periodic table, when you have a substance built of only the red ones, it means they have a covalent bond. So if I have, for example, water, H2O, it only has nonmetals, so it has a covalent bond. So, like H2O, because H2O, H is a nonmetal, O is a nonmetal, so this is those have covalent bonds. When you have covalent bonds, the substances have a covalence. And the covalence is basically the number of bonds that it can form. The number of bonds, and it's equal to the number of elements behind it in the periodic table. So if I have, for example, oxygen, I have 2 more elements behind it in the periodic table, which means oxygen has covalence of 2. Oxygen therefore can form 2 bonds. Hydrogen, on the other hand, is here. There's only 1 element behind hydrogen, namely helium, which means hydrogen can only form 1 bond. Nitrogen can form 1, 2, 3 bonds. Carbon can form 1, 2, 3, 4 bonds. Boron can form 1, 2, 3, 4, 5 bonds. You hardly ever will see boron. Mostly it's hydrogen, carbon, nitrogen, oxygen. Sometimes silicium, but mostly it will stay with the 4 of them. So if I have hydrogen, if I'm going to draw it, I take the O first because it has the highest covalence. We just found out that it has covalence 2, and this one has covalence 1. So it has 2 bonds. Hydrogen, on the other hand, only has 1 bond, so I can just put a hydrogen here and a hydrogen here. And now O has 2 bonds, each hydrogen has 1 bond, so now my covalence is correct. This is something you can do with all nonmetals, so with all elements with only nonmetals. Then there's the ionic bond. And the ionic bond, it occurs when you have something that is charged. So it's a bond between positive and negative. Like here, if I add the 2 of them, I get an ionic bond because I have 2 plus here and O2 minus here. Those things is what we call an ion. So an ion is a charged atom. So an ion is a charged atom, and that is why it's called an ionic bond. So an ion is a charged atom, and that is what we call ionic bonds. They mostly occur between metal and non-metal. So if you have a combination of a metal and a non-metal, it's an ionic bond. Like I have magnesium is a metal, oxygen is a non-metal, so the 2 of them would form an ionic bond. And then there's the metal bonding. So the metal bond, let's just make it like this. The metal bond obviously occurs only metals, and they have electrons moving around. That is also why they can conduct electricity. So if I have like the nuclei of all those metals, like you had here, with the protons and the neutrons in the middle and the electrons all around it, all these nuclei of a metal, they are all arranged, and all the electrons, the E minuses, they all just float around and they can move like this. So the electrons are free to move, and that is why they can conduct electricity.